In today's high-tech industrial world, there's this hidden problem, and it's quietly costing businesses an absolute fortune. It's like this invisible storm that's just creating chaos inside the electrical system. So today, we're going to dive into how to tame that power storm.
Picture this. Inside factories and massive industrial sites all over the planet, there is a constant, invisible storm brewing. We're not talking about wind and rain, of course, but about electrical instability. It is chaotic, it's unpredictable, and frankly, it puts everything you do at risk.
And here is the crazy part. The very tools that we designed to control this chaos, well, in a lot of cases, they're actually making things worse. So if the old solution is now part of the problem, what do you do next?
To really get a handle on this, we first need to connect two really important ideas: power quality and profit. Because make no mistake about it, unstable power is hitting your bottom line and it's hitting it hard. See, when your power quality is bad, you get hit from all sides. The utility companies, they can slap you with penalties for being inefficient. Your critical, expensive machinery, it can just break down without any warning. And worst of all, your entire operation can grind to a halt, costing you thousands, heck, maybe even millions in downtime.
So what's really behind all this? Well, it's about time we met the villain of our story. It's a piece of tech that's been the go-to standard for decades, but it's just completely outmatched by the needs of today's world. Let's talk about the capacitor bank.
Okay, so let's break down exactly why this old tech is failing us. We're going to zero in on three huge problems. Its vulnerability to something called harmonic distortion, a really dangerous risk of resonance, and how it just can't handle voltage sags.
First up, harmonic distortion. Now, the easiest way to think about this is just electrical noise. All our modern equipment, things like variable frequency drives or even LED lights, they create this electrical pollution that just contaminates your entire power system. It makes it unstable and dirty. And this is where you can actually see the capacitor's fatal flaw. At a normal frequency, everything's fine. It does its job. But the moment those higher frequency harmonics, that electrical noise, show up, the capacitor's resistance just plummets. It basically becomes a magnet for all that damaging noise, causing it to overheat and eventually fail completely.
And you know what? It gets even worse. When those capacitors and harmonics mix in just the wrong way, they can create something called resonance. This basically amplifies that electrical noise to insane levels. And, as this quote warns us, this isn't just about a blown fuse. We're talking about a massive safety hazard that can literally lead to explosions and fires.
But the harmonic noise isn't the only threat here. Nope. There's another really common event that puts incredible stress on these old systems, and that is voltage sags. A voltage sag is pretty much what it sounds like: a sudden, super brief drop in your system's voltage. It happens all the time in industrial settings, especially when you fire up a massive motor that just demands a huge surge of power all at once. And wow, this chart just lays out the consequence perfectly. So during the sag, the capacitor drains, but the second the voltage snaps back to normal, that capacitor tries to recharge instantly. Bam, look at that spike. The current surges from a normal 500 amps to a crazy 1500 amps. That's a 300% jump in an instant. That massive inrush of current is like a tidal wave crashing into your equipment. It puts an unbelievable amount of stress on the whole system, and that leads to damaged parts and causes your expensive gear to fail years before it's supposed to. Okay, so the old tech is failing. It's causing way more problems than it's solving. But what if there was a smarter way? Well, if the capacitor bank is the villain, then it's time to meet the hero of our story, the static VAR generator, or SVG for short. So unlike that old, slow, mechanical capacitor bank, the SVG is a totally modern power electronic device, and its superpower? Speed. It provides instantaneous, real-time correction to stabilize your entire power system. It's like a lightning-fast bodyguard for your power. So how does this thing actually work its magic? Well, it's really a simple three-step process. First, it is constantly monitoring the power system, every millisecond. Second, it uses smart electronics to instantly inject or absorb power exactly when needed. And the result? It holds your power factor, that key measure of efficiency, at a near perfect 1.0 all the time. All right, this is my favorite part. This is where we get to see the decisive victory of this new technology over the old.
Let's take a look at the dramatic difference it makes in a real-world manufacturing plant.
So what happens when you finally rip out that old, vulnerable capacitor technology and you plug in a smart, responsive SVG? This happens. Just look at this graph. On the left, before the SVG, you see total chaos. The power factor is all over the map, it's wild, it's inefficient. Then, that red line, that's the moment the SVG is turned on. Instantly, on the right side, the chaos is tamed. The power factor locks in right near a perfect 1.0 and just stays there. Now that is control. That is stability. So let's just put it side by side. It's a night and day difference, right? The capacitor bank amplifies noise, it's slow, and it fails during sags. The SVG, it's immune to that noise, its response is instantaneous, and it stays perfectly stable. It's a direct solution to every single problem we've talked about.
You know, when you see a chart like that, you realize this is about way more than just swapping out a piece of hardware. This is a fundamental shift in how you manage your facility's most critical resource, its power.
Ultimately, it all comes down to taming your power to protect your profits. So the real question you have to ask yourself is your system truly under control, or is that storm still brewing? Because in today's world, taming your power isn't just some engineering goal, it's a core business strategy.